Every year, they see up to 160 million tons of goods leave for the outside world round the clock. Since the start of 2013, China has been the world's largest exporter. Its manufacturing power has long been something of legend. Now this manufacturing power is being turned to the method by which Chinese-made goods reach the outside world. Another of the world's mega container ships is under construction at this Chinese shipyard. At 399 meters long, it will rank with the biggest in the world. When fully loaded with containers, it can sail for 40 days uninterrupted, a true leviathan of the seas. This is the first time a container ship of this size, with a capacity of 20,000 standard containers, has been built in China. For the engineers, precision is the greatest challenge in building this giant. They must work in all areas to a margin of error of less than 5 millimeters. Ensuring this precision starts with the cutting of the plates. 42,000 tons of steel plate is transported to a workshop in batches. A plasma cutter then cuts the plates in exact accordance with the design drawings to within a single millimeter. The heart of the shipyard is this giant dock, the size of 7 football fields. The dock is the yard's most valuable resource, so efficiency dictates that each vessel should occupy it for the shortest possible time. To speed the building process, the various sections of the ship are put together in modules away from the main dock. The original design of the ship splits it into 399 units, or modules, which can be assembled separately and simultaneously at various sites around the yard. These are then brought together for final assembly in the dock. Although broken down into 399 modules, each weighs many dozens of tons, and moving them around is not easy. One of the largest modules, the bridge and superstructure, is ready to be hoisted into position. It weighs over 600 tons. It will be lifted by 2 huge gantry cranes that themselves weigh 1,200 tons in total. The real difficulty is not in the lifting, but how to install it on deck to the nearest millimeter. It requires the precise coordination of dozens of skilled workers. The cranes get the bridge in place when suddenly a strong wind gets up. Even a 1,200-ton crane system can't hold a 600-ton bridge steady in the force 8 gale. It is decided to delay the operation. After a couple of hours, the wind drops. The welder sees the opportunity to make quick work of marrying the superstructure to the hull, and as ever, precision is the watchword. At the same time, in the hold, another group of engineers are conducting a test. A test frame the size of a standard container is lowered down into the vessel. In future, there will be 20,000 containers on board, each of which needs to have a precisely marked location.
我们通过这个模拟的那个箱位啊，就是把这个箱子放下来了以后，就是试一下这个一个舱室的那个大小。像今天的样子，就是我们提交给船东船检，必须要保证它每一个箱位要这个模箱要顺利的放下去，就是说允许在3个毫米以内，因为以后在航行当中大批量的集装箱全部要塞进去，要保证每一个箱位都要放到位。
In a few months' time, the Leviathan will plow across the oceans loaded with the treasures and trinkets, affordable goods that have benefited people from Atlanta to Zanzibar. While China is providing all manner of goods to the world, it is also importing products it needs. In particular, microchips, on which China spends more than $230 billion a year, even more than it spends on petroleum, and in fact, China's largest import. In 2016, China made more than 1.2 billion smartphones and became the world's largest producer and consumer of mobile phones. But the crucial chips on which the phones run all have to be imported. This situation may not last forever. Han Zhenggang is leading his team working on an important project to develop the next generation of 5G microprocessors. Its data speed will be 10 times faster than that of the fastest 4G chips. And the big plan is to get this to work on a chip of just under a half of 1 square centimeter.
我们5G 芯片可能涉及到的晶体管可能要在10亿到100亿之间啊。那这是什么样的一个概念？我们如果把一个晶体管等于我们一个人的话，那就是说我们5G 这个芯片里面的这晶体管的数目应该跟全世界的这个人的数量差不多。
It would be very complicated to organize the entire population on Earth to work together properly on a task.
其实应该是2派吧，3个一组，3个一组，这个3个一组。
Han Zhenggang's group uses a device costing more than1 million yuan to conduct a crucial experiment.
这个呢，你可以理解成为一个放大版的一个5G 的芯片。芯片的设计之前呢，我们要为了去验证这个芯片是否正确，我们需要通过这样的一个平台，能够100%重现我们的设计啊。那在这样的一个平台上面，把我们芯片所有的这个行为都模拟好，都验证正确以后呢，我们这个芯片的设计才真正的拿到工厂上面去生产。那个时候呢，那个芯片就变成一个非常非常小的一个面积的这样的一个芯片了。
The design is about to be tested, and the engineers are preparing for it.
意思我现在不是国信那个吗？国信远程登陆也有大公家。
To lay out billions of transistors on a 0.49 square centimeters chip, the engineers need to have extraordinary imaginations. It is like building an extremely complicated super city in a micro world.
我们在整个设计过程中，就是说我们要把所有的这些晶体管摆在合适的位置，通过一些连接，把所有的这个功能模块合起来，才能完成我们整个的一个工作。
It's like the data package for a high-definition movie downloaded from a simulation base station. The operation needs to be completed in a few seconds. This places high demands on the design. The final design is what will allow future 5G chips to support their greatly increased data transmission and processing speeds. China's chip manufacturers are looking for breakthroughs in many fields, including core chips that support high-speed railway operations, and electric vehicles like insulated gate bipolar transistors, IGBT. The 5G chip developed by Pan Zhonggang's group will appear in a new generation of smartphones. A new 5G era is coming. Another potential industry is aviation. The already busy skies above China will only get busier. There are currently nearly 3,000 aircraft flying more than 1.33 million passengers every day. The majority of these aircraft are manufactured in Europe or America. But that is set for a gradual change. The expansion of China's internal aviation market over the next 20 years will see the number of civil aircraft needed rise to over 6,000. This huge market has prompted Chinese engineers to design and build the C919. It takes more than 1 million components to build a C919, and each must be made to the highest standard demanded by the world aviation industry. Flight assembly engineer Zhou Qiwei explains some of the details.
我们现在来到的地方就是那个飞机驾驶舱，就是正副飞行员的一个正下方，是一个电子舱，它是全机设备最密集的地方之一，线缆也是最多，它涉及到的插头大概将近有200个左右，线束的密集程度也是全机最高的。
In modern aircraft, mechanical control systems are replaced by electronic ones. This creates an intensive network of sensors and controls that works like a body's neural system. C919 has over 10,000 wires, with cumulative length of nearly 80 kilometers. Each wire needs to be carefully installed, one at a time, by experienced engineers. It's a bit like heart surgery. And like operations on a human body, no mistakes can be allowed.
这么复杂，我怎么来保证这些我线跟图纸装的是一定是正确的？那它每个坐标点没有重叠的号的，它们所有的号在图纸上面都是唯一的。我每装完这个点以后，我会在那个电子表上打一个勾，证明我这个点是装完了。到最后我做复查的时候，我不是复查机上的实物，我是查我那个表，我表里没有打勾的，然后我上来复查。
Computers and meticulous management allow the engineers to complete this complicated operation efficiently and reliably. At the Aircraft Test Engineering Institute, 30 kilometers away, another and altogether more dramatic test on the C919 is being prepared. This test is conducted in a Chinese-built flight simulator called the Iron Bird. All the control systems are identical to that of the real aircraft. The test will be of a simulated catastrophic failure in the C919's flight control system. Zhao Jingzhou is the deputy chief engineer of C919. For the past few years, he has been working on the aircraft's core flight control system. This amounts to the most sensitive and confidential data held by any manufacturer.
几个系统都开了吧？行，那你到副驾驶位置。驾驶舱已就位，开始进入实验状态，拉起。
The simulated scenario is a high-altitude failure of an aileron on one wing due to sudden icing. It will cause a dangerous destabilization of the aircraft's flight attitude. If the flight control system fails to correct it in time, a catastrophic accident could follow.
把它的方位啊什么的调整。报一下飞机的高度，现在是4500英尺，178几。我们这边在设置飞控系统呢，是一个很重要的系统，里面的很多的技术呢是国外对我们有限制的，所以作为主制造商来说的话，我们必须要通过我们的积累呢，掌握飞控系统这个技术。故障已经注入。
One aileron is locked to an angle of 15 degrees by the computer system. The plane starts to roll.
飞机的右滚现在开始纠偏，感觉一下，在让飞机保持平飞之后的杆的一个操纵的。
No one would risk conducting a test like this in the air. Yet with the Iron Bird, the engineers can test the plane to the limits of its parameters. After extensive testing in the Iron Bird, the C919's flight control system achieves a faultless level of performance on its first real test flight. In the future, C919 will be a key part of Chinese air transport system. The mid-sized passenger jet will not only benefit travelers across the nation and other countries and regions to which it is exported, but its manufacture will support more than 200 enterprises and 200,000 skilled workers in the research and development. It has taken just 30 years for China to transform from an industrial backwater to the world's largest manufacturer. But manufacturing demands energy. China consumes nearly 6 trillion kilowatt hours of power per year. To provide this by thermal power plants alone, it will put huge pressure on the environment. Reduction of carbon emissions is a key goal under the Paris Climate Agreement of 2016. Nuclear power is one way to achieve this while keeping the lights on. Though nuclear power has zero carbon emissions, it does have other major safety issues. The engineers building China's new nuclear power stations must ensure safety cannot be compromised.
核裂变反应会产生巨大的能量，我们把这个能量通过蒸汽能机转换成电能，但是能量转换必须控制在安全范围之内。为了控制这些能量巨兽，我们 制造出了坚不可摧的大家伙。
The 10,000 square meter factory in Shanghai is making the latest generation of nuclear power units by the highest safety standards in the world. The factory can build the equipment to fit out 6 nuclear power plants per year. If all are put into operation, annual coal consumption will be reduced by at least 13.8 million tons. In a special workshop in the factory, the key parts of nuclear power units are being assembled. A specialized metal tube will be inserted into the giant evaporator. Nuclear fission produces energy, which heats demineralized water in the reactor. This heated water flows through pipes in the evaporator to transfer their heat energy to water on the outside of the pipes. This water then evaporates, and the steam produced drives the turbines to generate electricity. In the process of heat exchange, no contact can be allowed between the radioactive water heated by the fission reaction and non-radioactive water, which drives the turbines. These nickel-based alloy tubes are at the heart of this. The 1.01 millimeter thick tubes must have complete resistance to stress, corrosion, and cracking in a radioactive environment. They are the crucial components in a nuclear power unit. Their assembly is very demanding of the installation environment. The workshop must maintain a 100% clean atmospheric environment and a constant even temperature 24 hours a day.
CIP 现在是蒸汽发生器，是目前世界上最大的蒸汽发生器。所以我们现在看到的是这个 CIP 现在蒸汽发生器制造过程当中非常关键的一个工序——油心管的穿管工序。蒸汽发生器我们下部筒体这个整个长度有13米左右，要从一头穿到另一头穿管，要非常流畅地完成这个工序。它的控制的精度要求是按缪按斯来进行控制的，所以这个制造难度是非常大的。
To increase the efficiency of the heat exchange, the nickel-based alloy tubes need to be as thin as possible. The total length of the 12,500 1.01 millimeter tubes is over 300 kilometers. Each tube has to be precisely manufactured and individually delivered to the site, where it is carefully installed in the evaporator. To build a completed evaporator takes 50 days. On the other side of the evaporator, the work of 2 technicians is even more critical. Both mouths of each of the nickel alloy tubes passing through the evaporator will be fitted into pre-arranged slots in an end plate. These are the only interfaces between the U-tubes and the external world. The task of the 2 workers is to weld the ends of the tubes onto the plates. The quality of the welding work will directly determine whether there will be any leaks. The whole process is strictly controlled. The welding time is precisely calculated to exactly 80 seconds for each weld. No variation is allowed.